Hey guys, welcome back to MCQ. Today I'm attempting the physics paper from the International Advanced Subsidiary Level, Unit 2, Waves and Electricity, and it's the fresh paper of Jan 2021. So without further ado, let's get started. So the first question is, the unit of power is the watt, and we all know that. Which of the following is included in the SI base units for power? So guys, if you remember the SI base units, which includes the mass, time, length, temperature, amount of substance. So if we go out and cancel out the wrong terms here, Newton doesn't count off, so we'll just cancel it. Neither ampere, that's not the base unit. So we are left with kilogram and joule. So to differentiate between these two, so if I go about the formula for power, so the formula for power is W upon T, or work done upon time. And if we look closer to the work done, or just derive more formulas from it, so work done can be written as force into distance. And if we look at the units, we will have, there you go, kg into meter square s square. If we combine the force unit, that says the force is equal to mass into acceleration, which means kg into meter per second, and that's into d, which is meters. So that's how we get kg meter square s square. And now that we know that we have kg is as base unit, so our final answer will be B. And there you go, we're done with the first question. Moving on to the second question. The diagram shows a combination of three resistors of resistance X, Y and Z. And the question is, which of the following gives the total resistance of this combination? So guys, if you look closely onto the diagram, we can see that X is connected as series and Y and Z are connected parallel to each other. So the trick to find the answer in this question is, always remember guys, the resistance in series is never measured as 1 upon something or 1 upon X. So we can cancel out the options that have 1 upon X. There you go, you're left with A and C. Now what? So just write down X and then add. So to add the resistance of Y and Z, we will measure them in parallel. We measure the resistance as 1 upon R. So we have 1 upon Y, there you go, and we will add 1 upon Z. Now if you do some addition into these fractions, this Z will go up there and this Y will go up there, and it will become, there you go, X plus YZ upon Y plus Z. And if you look closely into the question, there you go, that's our answer, C. So C is our final answer, saving your time. Moving on to the third question. Ultrasound can be used to investigate organs inside the human body. Which of the following statements about ultrasound is correct? Remember guys, they're asking us to find the correct statement and not the incorrect one. Read the question properly. So if we look about the first option, which is all of the ultrasound is reflected at a boundary between different tissues. The reason this is incorrect is because not all of the ultrasound is reflected. That is the reason, because whenever we go about to hospitals, they ask us to do ultrasound. So whenever you look at the pictures that are being produced, so those pictures are kind of glitchy and you don't seem to have a lot of picture about it. So we can say that A cannot be a strong contender for the option. The B option is ultrasound travels faster in air than inside the body, and this is not true also, because the air is denser than whatever is inside the body. So we will cancel this off. There you go. The third option is that the ultrasound with a greater wavelength gives an image with a higher resolution. So if you guys know that 1 upon lambda is directly proportional to frequency. So what I mean by this is that the higher the frequency, the higher the resolution we get to the picture. So this is an incorrect option, because the lower the wavelength, the higher the resolution we get. And then we are left with the option D. So there you go, that's our answer. If we look at it, that ultrasound with a shorter pulse duration gives an image with a higher resolution. So guys, same thing repeats here, that whenever, if you remember that 1 upon T is proportional to f. So the shorter the time, the longer the frequency and the higher the resolution. So this makes sense. So we are done with the third part, that's the D. The fourth question is, electromagnetic radiation can be described in terms of a photon model. Which of the following demonstrates the photon model of light? Just double check the question and go about and just mark the important lines. That's the photon model of the light. There you go. And we will have a look at the options. So first option is diffraction patterns. So for this model, it is strictly dealing with waves and wavelengths, so that will not be a strong contender. Moving on to the P part, which is Huygens construction. This is also related to the wavelengths and the momentum. Coming back to the C part, which is photoelectric effect. Now this is the option we are looking for, the mechanism provided by the Albert Einstein, which is photoelectric effect, dealing with the photon model of light. So the photoelectric effect is what when you can say that the electromagnetic radiation ejects electrons from the material. And looking back at the D option of the last one, which is plane polarization, it is all about the light being polarized and then traveling into the perpendicular direction. So this is not the option. So there you go, C is the answer for the fourth question. Moving on to the last question of this video. Questions 5 and 6 refer to the following information. The diagram shows a circuit used to determine the internal resistance R and EMF epsilon of the cell. Corresponding values of potential difference V and current I were taken after adjusting the variable resistor. A graph of V on the y-axis and against I on the x-axis was plotted. Which of the following is correct? So to visualize the graph of V against I, what we can do is draw a diagram, a rough sketch. There you go, that's the graph of V against I. And if you remember the formula for gradient of a line or linear equation, that is, so we have four functions here, which is y as the first, m which you can say gradient, x is on the x-axis, plus c which is the y-intercept. So our y value is v here, and if we go about on the other side of the equation, we have the x value as I, so just mention it. There you go, labeling that. And if you remember from the circuit, we have an epsilon or EMF and a resistance which is internal. So the internal resistance is always written as minus R on the diagram, and it goes like this in this direction negatively. So it will start from something here, not from the origin, because we have a y-intercept. There you go, so we can write it as minus R. There you go. So if we have a look at the options here, the area underneath the graph is the total energy dissipated in the cell. This is a wrong statement, because that's not the area under the graph or energy dissipated under the graph. The second question or the option is the gradient of the graph is R. If you look closely, the gradient of the graph is minus R. So always remember the signs there, that's not the option. The graph shows that V and I are directly proportional. So this statement can only be true when it goes from the origin. So this is not the option, and we are left with the final one, which is the D part. There you go. And if we read it out, the y-intercept of graph is epsilon E. And if we write it down here, it does make sense. So we do have a EMF in the starting of the circuit when there is no I, or the I value is equal to 0. There you go. So our final answer for the fifth part is D. And thanks for watching, guys. Stay tuned for the second part of this question.